Hello guys, my name is Bob. Welcome to the Excel Math channel. In this video, I'm going to talk about defining random variable with probability density function or probability mass function. Alright, so in the previous videos, if you have watched, I kind of talk about a discrete random variable x, which represents the coin toss outcome, whereby x is equals to 1 if the coin toss outcome is head, and then x equals to 0 if the coin toss outcome is tail, with the probability of getting a head is p, and probability of getting a tail is 1 minus p, and the sum of these two probability is actually 1. And usually what we will do is that we will have a formula, all right, as you can see down here, p to the power x, 1 minus p to the power x, to allow us to find the probability of a particular outcome by substituting the numerical values of the outcome itself. So if I were to sub in x equals to 0, I will get probability of 1 minus p. All right, and if I were to get sub in x is equals to 1, I will get the probability of p. All right, so this is supposed to be 1 minus x instead of x. All right, so we call this a probability mass function. It's a very complex word, but actually it's just a formula in which if you were to sub in the numerical values of x, you will get the probability. All right. So normally a probability mass function or a probability density function defines my discrete random variable. All right. Or determines what kind of random variable it is. So in the case of this, probability mass function, it actually belongs to this particular name called the Bernoulli random variable. So the Bernoulli random variable is defined by this probability mass function with the formula p to the power of x 1 minus p to the power of 1 minus x, in which x can take in the values of 0 and 1, and you can find the probability for the corresponding numerical outcome 0 and 1. All right. So the same thing for a continuous random variable. Let's say, for example, I have a continuous random variable y, which represents the heights of students in school, and it ranges between 1.5 meters to 2.5 meters. All right. We understand that for each exact value, let's say for example 1.5000014 something something, it has a probability that is close to 0, but it's probably just 0.0004 or something like that. And then you have another exact value, let's say for example 1.50015, probability is close to 0, we have 0.0005 or something like that. All right. And the thing is that we want to have a formula, all right, in which it will, if we were to sub in, all right, the range of values of y itself, you'll be able to get the probability. All right. Don't forget that in the previous video I talked about, it's no point to look at just the point, just a particular value, numerical value of the continuous random variable, because the probability will be small. All right. And what we will usually do is that we will actually look at a range. So let's say if I want to look at the probability in which I will find a student which has a height, who has a height between 1.5 to, let's say, 2. All right. And I want to find out the probability, but at the same time, okay, I need a formula to actually do this calculation. So in a continuous random variable itself, we also have a formula, which is in this case is 1. This is 1 itself, or what we call the probability density function, in which in the previous video I actually talks about is actually the curve itself of the yeah, I mean the curve itself. All right, so imagine that we have let's just draw quickly. All right, x-axis represents all the x values, and then the y-axis represents the probability. And then this is the my curve itself. My curve starts from here to here, and then this is the x value. It ranges from 1.5 to 2.5, because y can take same between 1.5 to 2.5. And to calculate the probability, we just simply take the area under the curve. So we integrate this probability density function from 1.5 to 2.5. All right, in this case. All right, let's just make this as 2.5. All right, so for this kind of curve itself, or this kind of probability density function, it also defines a random variable. All right, so when you see this kind of straight line, right, straight horizontal line curve or value itself, we have a name for the continuous random variable, and this is called the uniform random variable. Let me just write down in white. It's actually called the uniform random variable. Okay, whereby to calculate the probability itself, okay, basically is defined by fx, okay, or the probability density function is defined by this particular formula. That means it's 1 if y is between 1.5 and 2.5, okay, and 0 otherwise. All right, so this probability density function defines the random variable. So if you see that this formula itself is 1 between 1.5 and 2.5 and 0 otherwise itself, this is actually a uniform random variable, which is a continuous random variable. And to calculate the probability of a range of values itself, you simply take the area under the curve to calculate the probability of a range of outcomes. All right. Okay, that's it for this video, and I hope that's clear. If you guys have any questions, do comment in the comment section below, and I will see you in the next episode. Thank you guys.